Welcome guys, James again, and today we're going to be going over the Chemistry 151-13 Ideal Gas GLA. We're going to be covering the challenge problem in Part D. So the problem reads, a sample of gas has a mass of 0.450 grams. Its volume is 112 milliliters at a temperature of 65 degrees Celsius and a pressure of 765 millimeters of mercury. Find the molar mass of the gas. Right away I noticed that these values that are given to us are not in the correct units, so I want to convert those over. When we're dealing with ideal gases, we want our volume to be in liters, our temperature to be in Kelvin, and our pressure to be in atmospheres. So we'll go ahead and do those conversions right here. If we're given 112 milliliters, and we know that there are 1,000 milliliters in 1 liter, when we divide these out, we'll have 0.112 liters. Our temperature is 65 degrees Celsius, and to go to Kelvin, we're going to want to add 273.15. That's going to give us a total of 338.15 Kelvin. And then finally, we're going to want to convert the millimeters of mercury into atmospheres. So we have 765 millimeters of mercury. We know there are 760 millimeters of mercury per 1 atmosphere. So when we divide these out, we get 1.01 atmospheres. The equation that we're going to be using here is PV equals nRT. We have the pressure, we have the volume, and we have the temperature. Now we also have R because that's a constant, where R is equal to 0.08206. If we rearrange this formula to solve for the number of moles, what we have is N is equal to PV over RT. I'm going to take this to another slide. So we have N is equal to PV over RT. On the other slide, we had V was equal to 0.112 liters. T is 338.15 Kelvin. And our pressure was 1.01 atmospheres. And we know R is 0.08206. So we're just going to go ahead and plug those numbers in. N is equal to 1.01 times the volume, which is 0.112, divided by the ideal gas constant, which is 0.08206, times 338.15 Kelvin. And if we go ahead and carry out this calculation, 1.01 times 0.112 divided by 0.08206 divided by 338.15, we get 0.00408 moles. Now we know that the molar mass of anything is going to be in the unit of grams per mole. So if we're given the mass in grams and we just solved for the number of moles, all we have to do is plug these two numbers in to get the molar mass. So we're going to have 0.450 grams divided by 0.00408 moles, and that's going to give us a molar mass. So we'll do 0.450 divided by 0.00408, and we have 110 grams per mole is going to be the molar mass of the gas. Thanks, and I'll see you guys next time.